factory. So what can we may do, for example, if we want to erect a building, so we need to design the beam and column or the various component of our building structure. So we can design beam and column in offices, and then we can fabricate these section in factory. And then what we need to do, we need to transport these section, and then we join them by certain devices. And these devices are called the connection. And these connection can be carried out in field. So we can connect various element of structure, beam and column, or maybe two column, or maybe one beam to the other beam with the help of connection. And there are different type of the connection that we are going to discuss today. So this connection might be welded. This may be fastener type. In the fastener type, we may opt for the riveted connection or maybe the bolted connection. So actually a design for the connection is the most important aspect of our structural design, because connection, they are transferring the load from the one structural member to the other structural member. So the design for this connection is more important than this the structural element itself, because if the connection fails, then it means that that is a failure of the entire structure. So maybe due to the applied loading, beam and column and all the other structural components, they are not undergoing the large deformation, or they are not undergoing the failure. Rather, the connection may breaks. So it means that we need to pay more attention toward the connection design. So here briefly we will discuss that what are the connection, what are the different type of the connection, and what are the design guideline for any particular type of connection. So connections are the devices used to join the element of structure together at a point such that the forces can transfer between them safely. So for example, we may need to join a beam with the help of connection with the column. So if the load is acting on the beam, and beam can withstand or can bear all this load safely, and then it is transferring that load with the help of connection to the column. If the column will be not strong enough, so the beam will not be able to transfer all the load to the column, and the connection may fail. So connection design is more critical than the design of the member. So it means that we may use sometime more factor of safety, or maybe a high strength material for the connection as compared to the structural member itself. The failure of connection usually means the collapse of greater part of the whole of the structure. So I will give you the typical example of a truss. So in a truss, we design all the members separately, and then all the members, they are joined or they are connected with each other at the joint with the help of gusset plate. So all members, they are connected with the gusset plate, and gusset plate, they are connecting with the all the other members. So all the members, they are not directly connected with each other. Rather, the first member, they are connected with a steel plate, which is which is called as a gusset plate, and then gusset plate is also connected with the other member. It means that force is transferred from the one member to the gusset plate, then from the gusset plate it is transferred to the other member. This means that design of this gusset plate and the number of the fasteners which are required to transfer the force safely from member to the gusset plate, it is also very important. So we will learn that how we can design different type of the connection. So when we talk about the design, so for example, if we are opting the fastener type of a design, then design mean that how many number of the fastener, mean how many number of the rivet or the bolts are required, and what would be the diameter of the rivet or bolt to safely transfer the force from member to the gusset plate. So we are interested in calculation or in computing the diameter of the rivets required and the number of the rivets required that may be uh, required to transfer the force from one member to the other member. Similarly, in case of the welded member, we need to see that how much thickness of the weld we need to provide, and how much length of the weld we need to provide to safely transfer the forces from one part, one structure member to the other structure member. So that we will discuss in detail in our today's lecture. So in general, relatively more factor of safety is provided for the design of connection. The rigid connection should provide sufficient strength and ductility. So we will discuss in detail. So rigid mean that any type of the connection which transfer the moment along with shear forces from one part to the other part is referred as a rigid connection. So rigid connection, you can say that that is the fixed connection, fixed. So wherever the negative moment or the moment is coming at the end, we need to provide the rigid connection. So for the time being, you can say that a rigid connection will be a fixed type of the connection which is transferring the shear force along with bending moment from one member to the other member. So we have already discussed some rigid type of the connection in our introductory lecture of steel structure, but I will show you the some rigid connection again in our forthcoming slides. So ductility means that the connection should have the required strength to resist all the applied forces safely, and it may have some ductility. It must go little bit or in undergo a certain deformation before failure. So failure should not be abrupt. So how we can make sure? We will study the guidelines in detail. So ductility is very useful for redistribution of stresses and dissipation of extra energy in case of earthquake. Actually, what is ductility? Ductility is capability of a material to undergo in deformation before rupture. So it means that we want that the material should deform before the final failure. Because when the material is deforming or the steel is yielding, actually it is converting the applied load into the deformation. So one type of the energy is being consumed to produce the deformation, which will avoid the abrupt failure or the what I must say brittle failure or the stress distribution will occur. So this stress distribution I will explain you in detail in the beam topic. So actually when a rigid support is yielded, then the behavior of the supports changes from rigid to shear connection or simple connection. So we have not discussed this topic at the moment, but I will explain this phenomena for the stress redistribution in our beam topic. So what are the different type of the connection? So we are having three types of the connection. Number one, we may weld one member with the other member, or we can use the fastener type of the connection. So with reference to the fastener, we are having two connections. One may be riveted and other may be bolted. So what is the difference between rivet and bolt? In the bolted, we punch the hole in both connecting member, and in case of the bolted, we are using the bolt and we are tightened with the help of nuts on the other side. But for the case of riveted connection, so rivet, these are maybe you can say that these are simple bolt without any threads, or maybe they are simple nail. One cap is already formed on the one side and they are being heated, and when they are at softened form or they are maybe in molten form, mild molten, or they are inserted into the hole, and then with the help of rivet gun they make the cap on the other side. And when the steel cool down or the rivet cool down, so due to shrinkage it provides the tight grip to the connecting member. So I have here one video, maybe I will show you the installation of the rivet in the field. So here I will explain that. So in this video, so first of all, they are having one maybe bolt or the rivet. They are heat up, maybe temperature may be around 700 and 800. At this temperature, the steel is in hot form, so it is little bit soft. So one person, he is maybe clutching with some maybe gear, or maybe and then it is inserting in this hole where it need to provide. And another person which is having a rivet gun, so one person he is holding the rivet from the downside, and another person he hammer the other edge which is plain with the help of this rivet gun, so that he is making the cap also on the other side. So when this rivet is cooled down, so it shrink. So during the shrinkage, it provide the a tight grip to this both connecting member. So I will show you this video again. You can also find a similar video on internet. So at least three persons are required to install a rivet. One person who is taking care of heating up the rivets in the furnace, and one person he is transporting or maybe holding the rivet, and a third person is installing the rivet. And overall process is, maybe you can say that it is noisy. So he handed over to this. So this was the installation of rivet. So we are having mainly these three type of the connection. So based upon these were the connection based upon the connection, and type of the connection based upon the forces which are being transferred. So first of all, we are having truss connection. So in the truss, actually this connection will be maybe pin-ended connection. We can simply say these are the pin connection. Actually, sometimes we may weld one steel member with maybe other with the help of the welding with the guzzer plate, and guzzer plate might be welded with the help of welds with the other member. But again, we are calling this connection truss connection as a pin connection. So why pin connection? Because center line of all member, it is coinciding or passing through the same point. So summation of the moment at any joint will be equal to 0. So that's why the truss connection are called only simple connection. So which are designed only to transfer the forces from one member to the other member, or from one member to the guzzer plate. So these are no design for the movement. So we will learn in detail that how we can design the connection for our trusses. Second is the movement connection. So actually the movement connection, they are mostly used in our frame structure which is comprised of beam and column. So what are the movement connection? We will study in detail. So movement connection are the connection which are transferring the movement along with shear forces from one member to the other member. And based upon the magnitude of the movement transfer, we may have fully rigid or fully constrained movement connection, semi-rigid or partially constrained movement connection. So fully rigid means they transfer almost 90% of the movement from one part to the other part. And semi-rigid, they are partly or partially distributing the or transferring the movement from one part to the other part. Normally range is between 20 to 90%. And simple connection or shear connection, which are not transferring any movement from one member to the other member, just transferring the shear forces. And splices are the type of the connection. For example, if you are designing a truss member and the length of the member is 5 meter, so it means that you need a section which must have a length of 5 meter. But in the market, 5 meter length is not available. So what we will do, we will use a maybe length of 4 meter and another length which is having segment which is having length 1 meter, and then we are joining this 1 meter and 4 meter segment to make a length of 5 meter. So for this same member, when we are joining the two small member to make a longer member, so we need to use the splices type of the connection. So you will see a splices type of the connection in our upcoming section. You will see some diagram. And bracket type of the connection. which are normally designed for torsion also. So rivet, I have already shown you the video. So we punch the hole with that in the both plate that we want to connect with the help of rivet. We are having one rivet which is may already have the cap on one side or may not have the cap on both sides. So this rivet is heated up in furnace. So one person he is placing this rivet into this hole and holding it up, and a second person which is having a rivet gun, it is hammering from the plain side or plain edge to make the cap on the other side. So that this process is called installation of the rivet. So uh, it is the old style connector. So it is also permanent. It cannot be open. So mostly if you see that in our Pakistan, most of the old steel structure or bridges, they have used the riveted type of the connection. So because they are permanent, so they cannot get loosened. So we don't need to tighten up maybe frequently due to loosening up, and further, nobody can open them. In case of the bolted, somebody can open the connection maybe to cause some destruction to the bridges. So nobody can open. So that's why they are safer than bolted connection. So they are permanent. So no feed heating and head forming. So silver they need the feed heating and head forming. So all process is carried out in the field. So they are having safety issue. What safety issue? So safety issue is that maybe all river they cannot be heated up at the same level, and when uh, maybe they are maybe tightening or making the cap with the help of rivet gun. So after cooling down, so the contact pressure may not be the same on all rivet. So there is some variability or maybe some variation in grip. Grip is the total distance between the two plates, total thickness of two plates which is holded by rivet. So we may not achieve the same level of tightness or the grip in all fasteners. So safety issue is that because handling, we are handling the hot rivet. So we need some safety measures also, or maybe some safety gears, maybe shoes, and the maybe we they need maybe also the goggles and safety dress, so that the person or the skill the labor may be prevented from any casualty in mishandling of rivet. So tension on cooling is not estimated accurately because cooling may not be same in our process, because when this material this cool down, so it shrink. When it shrinks, so it provides the tight grip. So load distribution is not as good as for bolt, because bolt we can tighten them properly, but they cannot be tightened properly. So here there are the picture you can see. So they have used riveted. So here you can say that lacing is used. So lacing is also connected with the help of rivet with this channel. And here you can see lot of rivets. So totally the rivets are used to make the built up section. And you can see in this truss member. So this built up section is connected with the gutter plate. So this is the gutter plate, this plate. And member is connected with the gutter plate with the help of rivet. So actually our target is that, for example, here, how many rivets are required to safely to transfer the forces safely from this member to this gutter plate, and then from this gutter plate to this member. So we are interested what would be the diameter of the rivet and how many rivets are required, and then we decide that what would be the placement pattern for the rivet, what would be the gap between them, whether we need to provide maybe in two row, maybe in one row. So row along the length. At any cross section maybe four. So this is gutter plate. So gutter plate, one member is not directly connected with the other member, rather it is connected with gutter plate, and gutter plate is connected with the other member. So this is connection. And pin, actually in case of the trusses, we sometimes we may actually provide actual pin support or hinge support. Here you can see a big pin is provided to serve as a pin support or hinge support for distress connection. Rarely used compared to the bolts and welds special in special projects only. So maybe on bridges, sometimes they provide actual pin. Here, installation of bolted connection. So I want to drag this. So here you will see that there are some person. So they are connecting one member, truss member with the other or Gaza plate with the help of bolted connection. So installation is rather easy. Maybe only one person can carry out the entire operation. Just to increase the efficiency, we may have more labor, but normally one bolt can be installed completely by this one single person. So after snug tight connection, so we can achieve the further tightening or full tightening by turn of nut method by using special wrench which are called tension wrench. So movement connections are also referred as a rigid continuous frame or uh, frame resistance connection, fully restrained connection. So actually I should not use the abbreviation. So rather I need to write completely fully restrained connection. Fully restrained mean that are maybe until 100% may not be 100%, but they are resisting or transferring the complete movement from the one end to the other end. So knee joints are typical joint. So knee joints are the joint which are of knee type, which is used designed to transfer the movement from beam to column. So they are assumed to be sufficiently rigid, keeping the original angle between members particularly unchanged after the application of the load. So total angle between beam and column, if it is 90-degree, even after the failure, angle will be remain 90-degree. So it means that the connection or the angle will neither increase or decrease. If angle is changing, it means that it is deforming due to the applied movement. So movement is not changing. So normally, movement resisting connection can be regarded fully restrained movement connection may be regarded if it is transferring more than 90% movement from one part to the other part, beside the full transfer of shear force. All type of the connection they will necessarily transfer the shear force, but they may or may not transfer the moment. If so, if they are transferring the movement along with shear force, they will be referred as a moment connection. So, for example, in your structural analysis, yes, I will show you example in the upcoming slide. First, let me discuss uh, the literature on this slide. These connections are particularly useful when continuity between the member of the building frame is required to provide more flexure resistance and to reduce the later deflection due to wind load. Both flanges and the web of the members are to be connected for this type of connection. We have already discussed. I will explain you in the next slide. End connection of restrained beam, girder and trusses shall be designed for the combined effect of forces resulting from moment and shear induced by rigidity of connection. So here I will explain. So actually this is the beam and we want to connect this beam with this column. If in the analysis phase you have considered the end condition as a fixed-ended condition for this beam. If you have considered fixed-ended condition, it means that you have analyzed this beam assuming the fixed-ended condition. For the fixed-ended condition, we always have negative bending moment at the end, and also this force reaction. So if you plot the shear force and bending moment diagram for a fixed-ended beam, so you will have a negative movement at the end and also the shear force at the end. So shear force, you can consider we are having a beam both end fixed and subjected to UDL load. Then negative bending moment at the end will be omega. Omega is the UDL load, intensity of the UDL load, omega, and L square by 8. Sorry, L square by 12. So maximum bending moment will be omega length, square of the length divided by 12. And maximum shear force at the end will be omega length divided by 2, omega L by 2. So it means that at the end we are having the shear force which is equal to omega L by 2 and the moment which is equal to omega L square by 12. So which is being produced or induced at the end. So actually we need to provide the same support condition that you have considered in the analysis, because your design of this beam is based upon this maximum bending moment that you have computed with some particular end condition. So here you know that if you sketch the plot the bending stress and shear stress. So neutral axis will be passing through the centroid of the web. One part will be completely in tension, bottom flange may be in compression, and the top flange will be in tension. Why? Because we are having negative bending moment. So negative bending moment means the moment tend to produce the tension on the top part. But anyhow, we know that the bending stresses, they are maximum at extreme fibers, which are the top faces or the outer faces of the flanges. So it means that the moment is causing the flexure stresses whose magnitude is maximum at extreme fiber. So therefore, these stresses must be transferred from this beam to the column safely. So we are connecting the flanges with the help of plate with the column. Then we are connecting the one part of the plate with the top with the flanges, and these plates are connected with column. Similarly, here you can see. So we here the bolted type of the connection is used. So one plate is welded from the one side. So plate is welded with the column, and the same plate is welded, connected with the help of bolt with flanges of this beam. So it means that the moment or the stress which are produced due to the movement at the extreme fiber are transferred with the help of this plate. And here you may also see that web is also connected. So web, if you know that the shear stresses, they are maximum in the web. If you know the horizontal shear stress, so they are maximum along the neutral axis or in the web. So, so web is transferring all the shears. So if only web is connected, then that is the simple connection or shear connection. If uh, flanges are also connected along with web, then this type of the connection will be referred as a movement resisting connection. So this is fully moment resisting because flanges and the web both are connecting the beam to the column. So they are transferring the movement with the help of plate which is connecting the flanges to the column, and the web is transferring the shear. We may have semi-rigid or partially restrained connection. So partially restrained connection, if they are transferring the movement less than 90%. So it means that they are not completely transferring the movement. So for example, if 100% movement is acting, produce, so 50% movement is transferred to the column, and due to 50%, the section is bent or rotate at the end. Although the relative rotation between the joining member is not freely allowed, the original angle between member may change within the certain limitation. Because rotation may take place. Rotation means that the angle between beam and column will not be remain 90 degree, but it will be changing due to the partial transfer of the moment. The transfer they transfer some percentage of the moment less than 90% and full shear, but they will always transfer full shear. It means that web will always be connecting. So here you can see a partially restrained connection. So web is completely connected. So all shear force is transferred from this web to the column. And here you can see that a very thin plate, maybe a very thin plate is connected from the flanges to the column. It means that that plate is not capable of transferring all the movement from this line to the other flange. So maybe they are transferring only some portion of the movement. So this is a partial restraint. So approximately they transfer the movement from 20 to 90%. So end movement may develop in the beam and maximum movement may be significantly reduced. Usually no advantage is taken of this reduction and beam are designed as simply spotted. So here actually in design we may either consider the ends as a fully rigid or maybe fully simply spotted. So we cannot consider partial restraint, but that is some provide some extra safety. So if accidentally some movement is acting on the beam by chance, so they can this small plate it can resist that very small accidental movement. So actually this beam will be designed as a simply spotted, but just to avoid any accidental movement, so a small plate is connecting the flange to the column. So why we are connecting? One of the reason is the difficulty of structural frame analysis for varying degree of restraint at the joint and unpredicted rotation. Unpredicted rotation means for any accidental movement which is coming. Further, LRFD specification states that a connection can only be considered as a semi-rigid if proper evidence is presented to prove it is capable of providing a certain end restraint. So if you have not performed the detailed calculation that how much movement is transferred, then you will consider this connection as simply spotted. And there are commonly used type of the connection in practice because their performance is exceptionally well under cyclic load and earthquake. So actually, I have told you that so the connection will be simple, but we have provided some extra plate just to take care of any extra or unexpected load, which is earthquake load or maybe any cyclic load, if it is this beam is subjected to. So it can take any extra moment. So simple or shear connection that have less than 20% rigidity. Actually, all type of the shear connection, they also transfer some moment, but the magnitude of the movement which is transferred from our beam to column is 20%. If they are transferring the movement less than 20%, so we are considering that the connection will be simple connection or shear connection. So they are considerably flexible and the beam becomes simply spotty due to possibility of the large available rotation. So you know that if both ends are pin, so we will have the maximum rotation at the end. And I believe that you have already derived the moment area method to compute the deflection or the rotation at simple spot in your mechanics of material. So movement may not be transferred in larger magnitude with the requirement that the shear is fully transferred. So here we are having the connection that we have already discussed. So only web is connected. Web may be connected thoroughly or maybe some portion may be connected depending upon the magnitude of the shear force which is acting in this beam. So you can see that flanges they are not connected. So it means that only shear forces are transferred from this beam to column. So bearing joint, there shall be sufficient connection to hold all part of the section and securely in place when column rests on the bearing. Actually, these are the connection which bear all the load. So let me check I have some diagram or not. Okay, no, I will give you. So actually when we are not placing the column end directly on the ground, so column bottom part of the column is welded with the plate, and then this plate is connected with some pedestal or maybe some concrete platform. So this base plate is designed for the bearing, as a bearing plate, or this joint is called the bearing joint because this plate is resisting all the load, or it is carrying the or bearing the all the load which is coming from the column. So there shall be sufficient connector to hold all part of the section securely in place when columns rest on bearing plate. So bottom end of the columns are welded with a plate which is called bearing plate, and this plate is connected with a column pedestal or concrete pedestal. So this type of the connection will be called bearing because this plate is bearing the all compressive forces of the column. So all compression joints shall be designed to provide the resistance against uplift and tension developed during the uplift load combination. So I will explain this type of connection when you will complete your truss design, because you need to provide one bearing joint for your truss design. Splices, these are used to extend the length of particular member. I have already explained. The two sides of the member may have same or different section. Splice joint is connection between two parts of the same member, whereas a regular joint is the connection of more than one member to the other structure. So normally connection is that if we are connecting two different structure members, but splices is the connection which is used to extend the length of the member. Just like I have given you the example, because if the member length is very large, maybe 5 meter, and 5 meter length is not available, then we may join a two segment, maybe one segment maybe 2 meter, and the second segment maybe 3 meter, and we can join them with certain connection. And this type of the connection will be referred as a splice, and we are connecting on the both sides. So bracket. So here you will see that this is the column, and normally we are having this plate, and this plate, which some part of this plate is extended outside, and then we are connecting this plate with the flanges of maybe I section or channel section. So load is applied at the ends of this plate. If the load is acting over here, so there will be some twisting or torsion will be produced along this bolt. So actually in this case of this, so this arrangement is called bracket. So actually the bolt which are connecting this plate to the flanges, they are subjected to twisting moment or torsion because load is acting or applied at the ends of this bracket plate, and when the load is acting, for example, it is acting in the downward direction, so it is having certain eccentricity from the center line of this bolt, so actually it is having a twisting effect, so it is not the bending moment. So brackets are the special type of the connection or devices where the connection welded or the fastener type, they are designed for torsion and also for the shear, because if you are transferring this force from this force, so actually if this force it tend to slide this plate with reference to the other, so all these connections they will design for shear along with twisting moment or torsion. So bracket are the connection used to transfer torque along with shear forces. The term bracket is generally used for an extra plate projecting out of the column and acting like the seat for the beam. So this is the extended portion. So a beam is rested on this two plate. So which is called, it means that this plate is a sitting plate. So load is acting on this beam. So for example, this is a load. So this load, if you are transferring from here to here, so this load is producing the torsion, and also this plate is causing the shear in all this board. So normally we provide the bracket type of the connection to support this crane. So you might have also seen one crane in our test floor lab. So you might have seen that this column, So bracket they are extended. On this bracket, this rail is connecting. So this is the rail which is placed on the bracket, and this rail is supporting the ends of this crane. So this crane can move along this rail. So this rail can only be provided on a bracket, and that bracket may be connected with this column. So types of the joint based upon the placement. So we are having two type of the joint depending upon the placement. One is butt joint and other is called the lap joint. So in case of the butt joint, both connecting member, they are their center line is coinciding with each other, and the gap between them might be filled by the weld, or this is the one member and this is the second member which is need to be connected. Their center line may coincide with each other, and then both section they may be connected with two extra plate. You can call them as a auxiliary or the additional plate, and we may use the fastener type of the connection. Fastener may be rivet, it may be bolted. So main thing is that center line of the one member is coinciding with the second member. So this is the butt joint. So we are having second type of the joint which may be called as a lap or overlap, where the member they are not directly placed side by side or opposite to each other, so their center line is not meeting. So center line of this member will be over here, and center line of this member will be over here. So that may be connected with the help of weld at the side, or maybe with the help of fastener. So actually the lap joint that we are providing in case of our truss connection will be lap joint. So how I will show you. So diagram I have already shown. Yeah, this one. So actually this is overlap or lap joint, because the center line of this member is not coinciding with this gutter plate. So gutter plate is lap with this our main member. So our connection will be lap joint, where the gutter plate is lapped with the member. So maybe we are connecting the flange with the gutter plate. So one plate may be thicker, other plate may be thin. So we are not having any butt joint. So rather we are having the lap joint. So here you will see that gutter plate is used on the both sides in case of the built-up section. So you can further read out from the book. So in welded lap joint, the minimum amount of the lap to be 5 times the thickness of the thinner plate, but not less than 25 mm. Okay, what does say that? Actually, this lap, distance overlap you can say from here to here, this length should be at least 5 times of the thinner plate. For example, this plate is the 5 mm thick, and this plate is 8 mm. So this thinner plate is 5 mm, 5 multiplied by 5 is 25. So minimum length of this overlap or lap should be 25 mm. That we need to provide. Minimum should be 25. Advantage of the lap joint. So actually, in case of the butt joint, we need to cut the both plates properly, and we need to provide maybe very small gap, maybe 1 millimeter, 2 millimeter. So proper cutting is required. But in case of the overlap, exact cutting may not be required. So this length may be more or less than, maybe it may be, for example, minimum should be 25, and it may be 30, it may be 35. It doesn't matter. So we not need maybe very large precision in cutting the length of the segment. So the plates of different thickness can easily be joined. Even though both plates are having different thickness, they can easily be connected. But here, if this plate is thin and this plate is thick, then we need to place some filler plate inside to maintain the thickness same at the joint. But here, even though the both plate they are having different thickness, they can simply be arranged in the lap manner and may be welded at the edges or may be connected with the help of fastener. Ease of filling. Pieces being joined do not require the preciseness in fabrication and do not and also do the other type of rejoin. So we do not need, so length may be precise. So the connection of our member with the help of gutter plate will be lap joint. So you can say that this is the angle section. So angle section is maybe welded with this gutter plate. So each member, each connection is designed separately. So here at maybe interior joint, all the members which are meeting at the gutter plate, we design this connection separately. So here you will see that one length is larger, another length is smaller for the channel. We will discuss why. So here, if we are connecting the web with one plate and that plate is connecting only from the one side with the column, that will be lap joint. These are also lap joint. So the pieces can be slightly shifted to accommodate the minor errors in fabrication or to make adjustment in length. So ease of joining, the edges of the pieces being joined do not need special preparation or usually shared for flaming cut. Actually here, the edge should be very smooth or they should be proper, because even though if you want to connect by the welding or here, but here we simply, in case of lap joint, plate may be cut from the edges with the flame or maybe with the gas cutter. They may not have a very smooth surfaces from the ends. Other joints are T-joint. So you can assume that this is the one plate and this is the other plate. We want to connect this plate in perpendicular direction. So we may place the weld here. So this is a T-joint. If we want to make a box girder, so this is the one plate, other plate at the end is placed in the transversal direction and we can provide the weld on this side. Edge joint, if we want to connect both plates at the edge. You might have seen in the gates, in the door for the decoration purposes, or in the arc-like action, we are connecting the both plates at the edges. So here at the moment, I will stop here and I would like to get your attention. Maybe I want to ask the question to the audience. So, Abdul Hasib Ahmed, can you hear me? Hasib?
Yes, sir.
Okay, what is the moment resisting connection?
सर उसमें वेब और फ्लैन फास्टनर से कनेक्टेड होते हैं दोनों.
No, the why we connect.
To transfer the forces.
What is the function of the connection of the flanges and the web? Let me know separately. Reason why we connect the flanges first. Okay, you do not know. Okay, Farhan 686. Can you hear me, Farhan?
Yes, sir.
Okay, just let me know what is the rivet. Rivet. What? How do you define rivet? What is the difference between rivet and bolt?
सर बोल्ट्स में हम दोनों में वो होल्स जो है वो पंच करते हैं, लेकिन जो रिवेटेड होता है उसमें हम वो मशीन के साथ, आपने वीडियो भी दिखाई थी, उसके साथ हम
अच्छा,
कैप बनाते हैं.
पंच दोनों में करते हैं यार. ठीक.
लेकिन सर वो कैप बनाते हैं रिवेटेड में.
ठीक हो गया. Haris Chaudhary, are you there? Haris Chaudhary, can you hear me? चौधरी साहब हैं मौजूद कि नहीं दूसरी तरफ? नहीं मौजूद। सिया जी तो आप भी नोट करते जाओ, मैं भी नोट कर रहा हूँ, मुझे बाद में आपने इनके रोल नंबर सेंड करने हैं। ये हारिस चौधरी साहब जो है ना,
ओके सर,
ये चौधरी साहब हैं और ये मौजूद नहीं है। हारिस चौधरी 2000। हसन जैन, आर यू देयर? हसन जैन,
Yes, sir.
what type of the forces are transferred by the bracket connection? Bracket,
सर उसमें एक्सियल फोर्सेस से ट्रांसफर होती है
बस वो
सर,
तो
वो मूवमेंट भी रेजिस्ट होता है
मूवमेंट कौन सा मूवमेंट होगा?
सर, बेंडिंग मूवमेंट।
बेंडिंग मूवमेंट आएगा। मैं आप अभी सोए हुए थे यार, आप
नहीं सर,
ठीक है। अच्छा, मियाँ हसन अली, मियाँ साहब आप हैं मौजूद? मियाँ साहब, मियाँ हसन अली,
यस सर।
आप बता दो ब्रैकेट, व्हाट टाइप ऑफ द फोर्सेस आर ट्रांसफर्ड थ्रू द ब्रैकेट कनेक्शन?
सर एक तो टॉर्जनल मूवमेंट होता है, दूसरा शेयर फोर्स को रेजिस्ट करने के लिए, वो ऊपर लोड जब लगता है तो वो मूवमेंट
ओके, गुड 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 हो गया, वेरी गुड। अच्छा, यस, सुबह कौन नहीं था? अच्छा, ओसामा रशीद, कैन यू हेयर मी?
Yes, sir.
अच्छा ओसामा, व्हाई वी कंसीडर द ट्रस connection as a pin connection?
Sorry, sir.
मैंने कहा नहीं यार, बताओ क्या हो गया है?
सर वो घर में गेस्ट आए हुए हैं तो मैंने लेक्चर लिया नहीं, मैं रिकॉर्डिंग देखूंगा।
रिकॉर्डिंग नहीं यार, अब क्या लेक्चर नहीं, मैं आपसे वैसे ही बताओ, व्हाई ट्रस कनेक्शन इज अज्यूम्ड एज ए पिन? अगर मैं वेल्ड करूं तो क्या वेल्डेड हो जाएगा?
नो आइडिया सर।
अच्छा, वैसे ही चलो बता देता हूँ।
Yes.
कैन देयर विल मे बी मूवमेंट एट द ट्रस कनेक्शन?
सर अगर तो वो फिक्स होगा तो फिर तो नहीं होगा।
क्या ट्रस के जॉइंट पे मूवमेंट आ सकता है?
ट्रस के जॉइंट्स पे? नो सर।
क्यों नहीं आ सकता? व्हाई, रीजन? if I am
क्योंकि
welding,
सर
if I'm welding one member with the guzzer plate and guzzer plate is welded with the other member, then
क्योंकि सर वो फिक्स कनेक्शन बन जाएगा।
तो फिक्स में मूवमेंट होना चाहिए कि नहीं होना चाहिए?
नहीं होना चाहिए।
फिक्स में नहीं होना चाहिए।
नहीं।
और अब यू आर इन द 5th सेमेस्टर, ठीक है, आप गैस को उनको हैंडल करो, उनको पता चल जाएगा तुम नलायक आदमी हो, ठीक है, माइक बंद करो, ठीक है। वो भी सुन रहे होंगे, गैस भी आ रही है, ये तो इंजीनियर माठा बंदा है। अच्छा, शयान, शयान साहब आप मौजूद हैं? शयान, शयान जावेद, सीआर, इसका भी रोल नंबर नोट करो या शयान साहब का भी। शयान साहब भी ना मौजूद नहीं है,
ओके सर।
ठीक है। ओके शयान, मे बी सीआर, मे बी आई वुड लाइक टू हैव अ ब्रेक ऑफ मे बी 12 मिनट, ठीक है। आई विल रिज्यूम मे बी लेक्चर एट 2:20।
ओके सर।
ओके, नो 56,
Yes, sir. Present.
50, okay 58, please also speak your roll
Present,
number
sir.
along. Okay, 59,
58.
okay
Present,
good.
sir. 59.
60,
Present, sir. 60.
61,
Present, sir. 61.
62,
62 present, sir.
63, 63, 64,
64 present, sir.
Okay, 67. Okay, good. 68. 68. 69.
Present 69.
70.
Yes, sir. 70.
Okay, 71.
Yes, sir. 71 present.
72.
Yes, sir. 72.
73.
Yes, sir. 73 present.
74.
Yes, sir. 74.
75.
Yes, sir. 75.
76.
Yes, sir. 76.
77.
Yes, sir. 77.
78.
Yes, sir. 78.
79.
Yes, sir.
80.
Yes, sir. 80.
81. 81. 82.
Yes, sir.
रोल नंबर बुलाओ ना, कौन सा 82 है? 82 प्लीज कंफर्म योर रोल नंबर अगेन. 82.
Yes, sir. 82.
हाँ तो आप 82 ने बोला. अच्छा 83.
Yes, sir. 83.
84.
Yes, sir. 84.
85.
Yes, sir. 85.
86.
Yes, sir. 86.
87.
Yes, sir. 87.
88.
Yes, sir. 88.
89. 89. 90. 90.
Yes, sir. Present. 90.
Okay. Okay. 91.
91 present, sir.
92.
92 present, sir.
93. 93. 94.
Yes, sir. 94 present.
Okay. 95 relegated 2017 CIV 95. 95 of 17 session relegated student. No. Okay. 95 of 2018
Yes, sir.
session. Okay, good.
Yes, sir.
96. Okay. 96.
Yes, sir.
96.
96.
97.
Yes, sir.
रोल नंबर बुलाओ दोबारा. 96 और 97 दोबारा रोल नंबर बोलो.
Sir, 97, sir.
Yes, sir.
ओके ठीक हो. 98.
Yes, sir. 96.
98 ओके हो गया.
Yes, sir. 98.
99.
Yes, sir. Present. 99.
100.
Yes, sir. Present.
101.
Yes, sir. 101.
102.
Yes, sir. 102 present.
103.
Yes, sir. 103 present.
104.
Yes, sir. 104.
And 290. 17 session. I guess Miss Fatima.
Yes, sir.
Okay. And 65. 2018 session.
Yes, sir.
Okay,
Present.
good. Okay, good. So I will restart the lecture and also start the recording. So first let me know, can you see the slides, gentlemen, students, CR?
Yes,
can you see
sir.
the slides?
Yes, sir.
Okay, ठीक हो गया. तो मैंने अभी यहाँ से स्टार्ट करना है वेल्डिंग. Okay, I will also start the recording. Okay, next is we will study the welding procedure and what are the different type of the welding method. So I'm not going to explain these two procedures in detail, and I believe that you can find lot of literature on internet, or maybe you can find some videos also. So normally the welding is a process in which metallic parts are connected together by heating their surface to a fluid state and allowing the part to fuse or flow together and join with or without the addition of other molten metal. So actually welding we heat up the both part, and after heating up, when the both parts or the connecting element they become molten, and then we join together. So when, which is called the fusing process. So sometimes we can add some extra metal to join them, or sometimes the both the parents elements they are joined together when we are heating them. So there is also one procedure which is called the friction welding. You can Google it on the YouTube. In the friction welding, so the both part they are heated up together by abrasion, and due to the friction between them, their surfaces they are heated up, and when the surfaces they are heated up, then they are kept with each other by holding them together, and the molten parts or the metal it fuse together. When it cool down, then we achieve the connection. So we may use some additional metal, or sometime we are not using any additional metal. So generally there are two type of the welding. Number one is the gas welding technique. This is an old technique and relatively maybe cheaper than the uh, electric welding. In gas welding, a mixture of oxygen and acetylene gases is burned at the tip of torch or a blowpipe held in the welder hand. So actually they are mixing two gases, and after when they are mixing two gases, and when after mixing they are heated up, and we achieve a flame which is having a very high temperature. So normally these two gases they are kept in a separate cylinder, and they are mixed up with maybe gun or maybe torch which is held by welder. So here you can see that normal the welder it is having two cylinder with pressure regulator. In one cylinder there might be acetylene gas, in the second cylinder they might have oxygen gas, and here they are having the welding torch, and here with this valve they are mixing both gases together, and they are heating up the flame, they are burning these two gases. And when they burn these two gases, so these gases they burn at a very high temperature, and due to very high temperature the steel surfaces it can be melted. So the melted steel surface they can be joined to achieve the welding or to achieve the firm connection. So normally the temperature is very high, and for the steel, so melting temperature for the steel is around 1650 degree. So it means that the gas flame is having the temperature more than maybe 1650, around 2000. So in this way, the welding can be achieved by mixing the two gases. So that's why this process is called the gas welding. So additional metal is introduced. So here you can see that they are having additional metal rod. So this additional metal rod is used to connect two plates, and this rod is molted with the help of high flame temperature. So gas welding is rather slow process as compared to the other mean of welding, and is normally used for repair and maintenance work. For the small maybe touch-up work, maybe for the repair work, but not the fabrication or for the welding procedure at the large stage or the at mass level. So electric arc welding, it is similar to the gas welding, but instead of the gases, so electric current is used. So in arc welding, an electric arc means spark is performed between pieces. The pieces of the metal surface which are being welded are connected to the negative terminal of the battery. So we need very high voltage battery. So the pieces that we are welding, that we intend to weld, are connected with the negative terminal of battery, and an electrode. Electrode is the extra metal or the steel rod which will use to weld the two pieces or two connecting surfaces are held in operator's hand with some type of holder connected to the positive terminal of battery. So electrode which is held by the welder uh, is connected with the positive terminal of the battery, and the steel surfaces or the member which are to be welded are connected with the negative terminal of weld. So when, and these are connected with very high voltage battery, electrode is brought closer to the pieces which are to be welded. So due to the high potential, the current passes from positive to electrode and through the air. And due to very high resistance in the air, a lot of temperature is generated. And this temperature helps to weld the electrode or to deposit the molten uh, electrode or the molten steel to join to connecting member. The arc is continuous spark which upon contact bring the electrode and the piece being welded to melting point. So when electrode is brought near to the pieces which are to be welded, so due to the very high voltage, current intend to pass from the electrode to the pieces which are to be welded. The resistance of air or gas between the electrode and the pieces which are being welded change the electric energy to the heat energy, and this heat energy increases the temperature between 3100 to the 5500 degrees Celsius. And we know that if we want to melt the steel, we need the temperature above 1650. And due to a very high temperature, so steel is melted and steel which is also used in electrode, it is also melted and it is deposited on the surfaces which are to be connected. So in electric arc welding, the metallic rod which is used as the electrode melt off to the joint as it is being made. So electrode, the metal which is in the electrode, it is melt off and it is deposited on the two surfaces or two member which are supposed to be connected or welded. Hence, the type of welding electrode is very important as it is decidedly affect the weld properties such as strength, ductility, and corrosion resistance. So actually the two pieces which are to be welded are joined together with the electrode or the metal which is used in the electrode. So electrode strength or the metal which is used in the electrode should be more than the base metal. Base metal means the pieces which are to be joined. So the strength of the electrode may affect the efficiency of the joint. Efficiency means the strength of the joint, ductility, or its corrosion resistance. So here you can see this is electrode. It is connected with the electrode or positive part of the battery, terminal of the battery, and the base metal, it is connected with the negative terminal of the battery. So what are the advantages of welding? Welding structure allow the elimination of a large percentage of gutter plate and splice plates necessary and which are necessary for riveted or bolted structure, along with the elimination of the rivet or the bolt hole. So actually at the moment it is difficult for me to explain because we haven't started the design of connection. But actually I would like to give you the one statement. If we are using the welded connection, the size of the gutter plate required will be less. If we are using the fastener type of the connection, we need larger gutter plate to join the member to the gutter plate. Let me try to explain. So here we are connecting this angle section with the help of welding with this gutter plate. So let's suppose if we supposed to connect with the help of fastener. So let's suppose this may be bolt, and we need at least 2 bolt to connect. For your example, I am explaining. So we need 2 fastener to connect this. Actually, in this case, I told you that when we are providing the fastener, we will see when we will finish our connection design. We maintain minimum center to center distance. So center to center distance between these 2 bolts should be 3 times of the diameter of the fastener. And similarly, edge distance from the center of this bolt to this edge should be 1.5 D. Similarly, we need to provide the edge distance from this center to the other side. It means that if we want to provide the edge distance to this gutter plate on the other side, so in that case, we need the gutter plate of this much size. So this size will be the edge 1.5D from here to here. It means that in that case, we need a larger size of the gutter plate to accommodate the minimum edge distance. But for the case of the welded, we just need small gutter plate. So for the fastener type of the connection, we may require larger gutter plate size because we need to maintain minimum center to center distance and also the edge distance. So welding requires appreciably less labor than does riveting because one welder can replace the standard 4-person riveting crew. So in riveting process, maybe at least 3 to 4-person are required as a crew member, but in welding maybe only one. However, we need a properly very skilled person. A welder should be properly skilled. So maybe because the weld quality is based upon the skill of the welder. If a welding is placed poorly, so it may cause the failure to the complete structure. Because a poorly installed weld may create many problems. So in welding process, we need a properly skilled person. Welding has a much wide range of application than riveting or bolting. So all type of the member, they can be connected with the help of weld, but certain section cannot be connected with other member with the help of fastener connection. So consider a steel pipe column and that which is difficult and the difficulties of connecting it to the other steel member by riveting or bolting. So a pipe section cannot be connected with the help of rivet or fastener connection. So, but with the help of weld, it can easily be welded with the base plate or with any other member. Welded structures are more rigid because members are often welded directly to each other. Rigid means that they can resist a larger bending moment. The connection for rivet or bolted structure are often made through connecting angle plates which deflect due to the load transfer, making the entire structure more flexible. So actually, for the fastener type of the connection, we need some extra angle section to connect one part of this section with the other, which can also bend or deflect due to the applied loading. So it means that the welded connection may be more rigid as compared to the other type of connection. On the other hand, greater rigidity can be a disadvantage where the simple end connection with little moment resistance are desired. So sometimes extra rigidity may be having some disadvantage because the behavior of the structure may become brittle. So welding changes or repairs are quick and easy. So if there is a welding failure, we can easily repair it. And welding has a relatively silence operation, but riveting, you have seen the video, so it is much noisy procedure. So fewer pieces are used, and as a result, time is saved in detailing and fabricating in the field direction. So welding is the quick procedure. So, but other type of the connection, they may take more time, because actually you can see that, okay, you can maybe argue the bolted type of the connection, they can easily be accommodated, but you need to punch the hole. So punching the hole to install the rivet, it also itself takes a lot of time. So welded connections are not recommended for temporary connection, where the bolts are preferred. Temporary mean that for scaffolding, for temporary offices, maybe site offices, that we need to maybe deassemble and re-erect again. Welding gives truly continuous structure with smooth and clean surfaces. So that may be more aesthetic. So type of the weld depending upon the weld shape. So depending upon the weld shape, we may have different type of the welds. So number one is the groove. Groove means that where we provide certain groove or certain gap between the two plates which are to be connected. So normally, in case of the welded connection, we do not need to connect or contact the two connecting surface. Normally, a gap of minimum, maybe maximum gap of 1 millimeter is kept, and then the gap is filled with the molten or the electrode or the welding. So with, and when we are filling this gap by the molten electrode, so this is called the groove weld. So when we want to connect a plate with another plate which is perpendicular, then we need to provide the weld on the both sides like this. This is called the groove weld. The type of the weld is used in approximately 15% of the construction. So most of the time we are using the groove weld. So actually, sometimes just to increase the area of the connecting surface, we also may provide some cut at certain pattern just to provide more strength. But here, if we are filling this gap with the weld, so weld may not be properly filled thoroughly. So there might be some bubbles. So for this purpose, we may have different type of the finishing surfaces. So if the two surfaces, they are brought parallel to each other and they are connecting with the help of groove weld, so the shape of the weld is square and it is denoted by two lines. So it is used if the thicknesses of the plates are less than 10 mm. So if the plates which are to be connected are having the thickness more than 12 mm or half inch, then we cut the both surface into the V shape and then fill this gap with the weld. So that is called single V. We may have double V configuration, bevel configuration, one plate is flat and other is inclined. K configuration or double bevel, and it is denoted by the K symbol. This is single U, double U, single J or double J. So any pattern may be used depending upon the thickness of the plate which are to be connected. So fillet weld. So fillet weld, owing to their overall economy, ease of fabrication, and adaptability, are the most widely used in approximately 80% of the construction. So it is actually triangular filling of the weld around the overlapping edges. So fillet weld, actually this is not the, you can say that this is actually triangular shape. Let me sketch, if I can sketch this weld over here. Maybe new slides, or maybe in some slide I may have some fillet weld. Okay, no problem, I will sketch it over here. So this may be the fillet weld. You can see that it is provided in triangular pattern, and this is the length of the weld. So this is provided along the length. So, and this weld is called the fillet. It may have this triangular shape or maybe any convex or concave shape. So this is along the length, and the cross section is like this one. This is fillet, triangular shape or maybe concave. So mostly we are providing this fillet type of the weld in our most of the welding. So it is actually triangular filling of weld around the overlapping, and which is having a certain length. Slot or plug welded, I will not explain, but I will explain. Slot or plug weld mean that one plate, we are only punching the hole only on one plate, and on the other plate we are not punching any hole, and if we are filling this surface with the weld. So when we are filling this surface with the weld, so this weld on the other side is connected with this plate. So this is called the plug weld or slot. So if we are punching the hole in one plate, that is the plug. If we are having this type of the shapes, that is slot, or we are making a slot. So slot is filled with the surface. So intermittent weld. So intermittent weld, I will show you. For example, here, this is, for example, you can say that I want to make an I section with the help of 3 plates. Let me sketch the diagram on the same page. Okay, let's suppose I want to connect these 3 plates to make an I section. So from the cross section, so we need to provide the weld on the one side and similarly on the other side also. So just see that we need to weld from here, and also we need to provide the weld on the other side also. Here. And actually, length of this is at the cross section. So if the length of this plate is maybe 1 meter, so we are not welding along the length, complete length thoroughly. If we are welding along the length is also 1 meter equal to length of this member, then this weld will become very expensive. So we provide this weld into different small segment. So this weld can be provided intermittently or in different patterns. So this is here. So if I cut this section here, if I cut this section and you are watching from the top, then you are having this. So this is the top face of the plane, this is the web thickness. And along the length, we are connecting by placing the weld on opposite side. So this weld 1, you can say that this weld 1 is this, and this is weld 2. And we are not welding thoroughly along the length, rather we are providing the weld at certain into a specific length at certain gap. So this weld is called intermittent. Intermittent means that this continues. We are providing at certain interval to save the electrode. So this is called the uniform intermittent weld. This is stagger. Stagger means that weld are not uniform. So opposite weld we are not having any weld. So they are providing in the staggering format. So effective length of any segment of intermittent fillet weld shall not less than 4 times the thickness of the weld. So this length of the weld should be minimum of 4 times of thickness of the weld. So thickness of the weld, we will see that what is thickness of the weld. So thickness of the weld here, let me explain here, but I will also explain in my next lecture also. So thickness this is the thickness of the weld. So thickness of the weld is referred as this one from here, and also thickness of the weld, this is also same. So this length should be at least 4 times of this thickness of the weld, minimum. Normally it is always more than 4 times thickness of the weld. So minimum effective length of one weld segment should be 4 times thickness of the weld, but should not be less than 38. So 38 or 4 times thickness of the weld, whichever is the larger. In lap joint, the minimum amount of the lap shall be 5 times the thickness of the thinner plate we have already discussed. Lap should be at least 5 times of the thickness of the thinner plate. So these are certain symbols. Actually, when we are designing the weld, so we need to show the weld on drawing and how we can read them. So we can read them by this way. So weld, this circle show that we need to weld a surface from all sides. Arrow show that we need to carry out the welding in the field. Flush contour. So if the shape of the weld is this one, that is the flush contour. Maybe triangular. And sometime, if I may have, yes, if the welding is this shape, this is convex, this line is not flat, or we may have the face as a concave downward. So in that case, we have to denote by this symbol. This is convex contour, this is concave tour. So let me whether I have some option to sketch this type or not. Yes, I guess I can sketch. So if we are having this weld shape, this will be shown by this convex contour. So you may have this contour will flush on inside. But anyhow, you got the idea. So this type of the weld will be concave weld. And how we show? So actually, we are showing the weld by a line arrow. So a weld is pointed with this arrow. So arrow show that this weld is having this particular specification. And then we are having this other horizontal line where we show the designation of the weld. And sometimes we are using this tail, but most of the time we are not using this tail. So at this joint, if we are showing the arrow, it shows that we need to weld this surface which this arrow is pointing to from all around. If this flag is there, so this flag shows that we need to carry out the welding in the field. So here we may have either symbol D or G. So if G show that we need to show the weld size on the arrow surface. So if the weld is carried out on opposite side of this arrow, then we need to show the symbol on this side, which is referred as a D. And if we need to show intermittent weld, we need to show the weld length at pitch. So pitch is the center to center distance between two weld, or we show this L by this. So when we are showing the weld, so first we are showing the what is the thickness of the weld and what is the length of the weld. So I will explain from here. And further, T is the specification for tail, S is the depth of the preparation of the weld size, E, sometimes we do not show the E effective throat, we just show the S value. F is the finishing symbol. So just we show this symbol, sometimes we do not show. Straight line is that fillet weld with straight contour. It may be convex or concave. So you can read out this symbol here, but I would directly like to explain from here. This symbol indicates that this I am pointing toward the weld. So this symbol indicates that the thickness of the weld will be 6 millimeter and the length of the weld will be 150. And weld we need to weld toward the arrow side. And here the arrow is pointing toward the weld, and this shows that 12. We need to show a fillet sign over here. This show we need to use a fillet weld whose thickness is 12 millimeter, and this is the intermittent weld. Intermittent weld length of the weld will be 50 and the pitch will be 150, or the length of the weld is 50 millimeter and which is provided at a gap of 150 millimeter. So 150 is the pitch. What is the pitch? Distance from center of this weld to this weld, not clear distance. So it is pointing out, for example, if I will show this weld, let me copy this symbol from here. Actually, let me delete this. Yes. or Control Z. This symbol is supposed to be on the downward side. This indicates that this weld is having the thickness 12 millimeter and the length of the weld will be 50 and it will be provided at a pitch of 150 millimeter. Center of the one weld to the center of the other weld will be 50. So intermittent weld of thickness 12 mm whose length is 50 millimeter and pitch is 150 millimeter is provided. And on the opposite side means that actually this weld should be on this side, opposite to this plate. So because sometime on our drawing sheet we do not have the space to show the arrow, so sometime we need to provide the weld on the other side. So actually this will be more appropriate if I will show you from here. Yes, that is more appropriate. So here I am showing this. So actually weld is provided to the other side of the plate. So that's why you might have seen that the symbol is shown to the other side of the arrow. So if this symbol is on the arrow side, then we must show this side. So actually we do not have the place to show the symbol, so it means that we need to plate this weld, weld this plate to the other weld whose thickness is 12 millimeter and that is an intermittent weld of length 50 millimeter with a pitch or center to center distance of 150 millimeter, and weld is to be provided to the opposite side of the plate. So symbol shows 12 mm thick fillet weld on a far or opposite to the arrow side. The weld is intermittent with a length of each segment equal to 50 mm and pitch center of the one weld to the center of the other second weld is the distance is 150. So this symbol indicate that we need to weld on the both side of the plate, on the arrow side and also to the other side. Welding must be carried out in the field and the thickness of the weld should be 6 millimeter and the length of the weld should be 150. This indicates that we need to weld whose thickness is 7. We need to use staggered weld, intermediate staggering pattern, and the length of the one weld will be 50 and the pitch of the weld will be 150, and we have to use the staggering pattern. A staggered intermittent weld will be used. Actually there is a mistake. 7 mm. 7 mm fillet weld will be used and the length of each segment will be 50 mm and center to center distance will be 150. So this will be staggering. Okay, next question arises that how we can achieve staggering. Okay, in staggering, distance from this center to this center will be 150 and on the other side the first weld will be provided at half pitch with reference to the weld on the opposite side. Distance from here to here stagger will be 75, then center to center distance will be 150. So pitch is a distance from the center of the one weld to the center of the weld on the from the center of the one weld to the next weld on the same line. Stagger is a distance from the center of the one weld to the center of the weld which is on the second row or in the transversal direction. So I will stop here. So I will start from this place in the next lecture because I need to explain many terminologies. So before winding up, I will check the attendance and I will also maybe ask some question. Okay, who is HB 405304?
सर हसन भट्ट नाम है वैसे इसका।
हसन भट्ट ये है कहाँ पे? सुबह था पहले भी सुबह के लेक्चर में?
सर आई थिंक एब्सेंट ही था आप कह रहे
नहीं ऑन है, अच्छा नहीं एब्सेंट था। इसका रोल नंबर क्या है वैसे?
सर 99 रोल नंबर
99। अच्छा 99। तो ये अब किधर है ये?
सर अब वो शायद माइक ऑन कर रहा था, उसकी आवाज नहीं शायद आ रही। अभी उसका माइक ऑन तो हुआ था एचपी का।
ठीक है, ठीक हो गया। अच्छा हु इज ये सिविल cover some more slides because otherwise if I will start now there will be the breaking, discontinuity will not prevail, so it is better to start from the next lecture. Okay, anyhow I will stop here and I will conclude the lecture. So inshallah see you the next time. Allah Hafiz.